Welcome to chemical equations. So in a chemical equation, we want a written representation of a chemical reaction using chemical formulas. So we have reactants on the left side, we have products on the right side, so we may write this as something like A plus B yields C plus D, or we might actually write out real compounds or elements there using their chemical formulas or element symbols. So the reactants are starting materials of our reaction, they're used up in our reaction, they're listed on the left side. The products are on the right side, these are our ending materials of our reaction, this is what we end up with. Products are formed during our reaction, so we use up our reactants when we're producing our products. So for something like the combustion of methane, we have a chemical equation that looks something like this. We have methane plus oxygen gives us carbon dioxide plus water. So methane and oxygen are our reactants, carbon dioxide and water are our products. Now, atoms are not created or destroyed during a chemical reaction. This is why mass is neither created nor destroyed. All we're doing is moving around atoms, we're bonding them in different ways. So the chemical equation must be balanced for numbers of atoms of each element. So the carbon atoms that we have on the left side must be the same as the carbon atoms we have on the right side, and the same for oxygen and hydrogen and so on. So the balanced methane combustion reaction looks like this. So we've added this 2 coefficient in front of the oxygen and a 2 coefficient in front of the water. So again, the coefficient is the number in front of a compound in a chemical reaction that represents how many molecules of that compound are involved in that reaction. So we have this coefficient and that coefficient. We haven't written anything here in front of the 2 carbon-containing molecules, compounds, because we're assuming there that we have 1. So we have 1 methane molecule reacting with 2 oxygen molecules to give us 1 carbon dioxide molecule and 2 water molecules. Now remember from earlier video that the subscripts here, this 4 and the implied 1 there, this 2 here, the implied 1, the 2 here and the implied 1, those subscripts tell us how many atoms of the element immediately to the left of it we have within that molecule, within each of those molecules. So in this case, we have 2 atoms of oxygen within each molecule, and we have 2 molecules. So if we want to draw this out, we have a molecule that looks like that. We have 2 oxygen atoms bonded together, but we have 2 of those molecules together. In this case, we have just a single molecule containing 1 carbon and 4 hydrogens. In this case, we've got 2 oxygen atoms bonded to a carbon. In this case, they happen to be doubly bonded. Here we have 2 hydrogen atoms bonded to an oxygen atom. But we have 2 of those, so I need to draw another one. Okay. So we've got 2 groups of atoms, 2 molecules. Within each molecule, we have 2 hydrogens and an oxygen, but altogether, we have 4 hydrogens and 2 oxygen atoms. So that was chemical equations.